Welcome to the Test Guild Performance and Site Reliability Podcast, where we all get together to learn more about performance testing with your host, Joe Calantonio.
Hey, it's Joe, and welcome to another episode of the Test Guild Performance and Site Reliability Podcast. Today, we'll be talking with Michael Sage all about how to practice chaos engineering in a real-world example of how it can be done in the banking industry. If you don't know, Michael is a solutions architect for Gremlin. He has over 20 years of experience from system operations, software delivery, performance management, and prior to joining Gremlin, he's been part of all the big performance companies that you've probably heard about, like Mercury Interactive, Hewlett-Packard, groundbreaking startups like New Relic, BlazeMeter, and Sauce Labs. So he really knows his stuff. Really excited to catch up with him. It's been a while. You don't want to miss this episode if you want to learn about the hottest topic in performance engineering, chaos engineering. Check it out. This episode is brought to you by SmartBear. Listen, load testing is tough. Investing in the right tools to automate tests, identify bottlenecks, and resolve issues quickly could save your organization time and money. SmartBear offers a suite of performance tools like Load Ninja, which is a SaaS UI load testing tool, and Load UI Pro, an API load testing tool to help teams get full visibility into UI and API performance, so you can release and recover faster than ever. Give it a shot. It's free and easy to try. Head on over to smartbear.com/solutions/performance testing to learn more. Hey, Michael, welcome back to the Guild.
Thank you very much, Joe. It's great to be here. It's been a while.
Yeah, it's been over 6 years. Last time I checked,
Yeah.
I think you were in episode 75, which was like 2014, 2015. So it's crazy. So you've been all over the place. What's new? Is there anything I missed in your bio or before we jump into it?
Just a lot of ground has been covered over the last few years. I mean, the whole industry moves so fast these days, right? I mean, Kubernetes is everywhere. I don't even think that was much of our discussion last time we met. It's really exciting. Chaos engineering, definitely one of the cool new topics. I'm super thrilled to be at Gremlin. It's new for a lot of folks. So what we're doing out there is, it's partly educational, which I really enjoy doing, showing people how we do this, talking about strategies for chaos, how it integrates with observability and performance and the other things that I've done in the last 10 years or so. So it's an awesome time.
Awesome. So it seems like site reliability engineering is now the hot topic. You've been in pretty much every phase of performance engineering, it seems like, through actually load and stress testing, monitoring, even been at some of these vendors, cloud vendors, where you run everything in parallel in the cloud. So why chaos engineering? Why Gremlin?
That's a great question. Something that occurred to me recently it's in general sort of our relationship to failure or performance degradation. For so many years, I mean, really 2 decades, it's been something to avoid for me, right? Just be afraid of failure, be nervous about failure, be anxious about failure. This kind of constant push to protect ourselves, and it's almost always feels defensive, right? And something is always going to fail, and then we go try to figure out why. And it's interesting to think about chaos engineering now because it's the opposite approach. It's embracing failure, going toward failure, creating failure on purpose, which it's kind of interesting. It's sort of like we just realized at a certain point that, okay, we're not going to be able to stop these outages from happening, no matter how hard we try. We have shorter release cycles with Agile. We've containerized everything. We have auto scaling and redundancies and failovers throughout our architectures and all these things that we put into place to try to protect the app, to try to keep our availability meeting our service level objectives, and still things fail. And it was we finally got to this place where the best way to get in front of this is to make it happen on purpose in a controlled way, and then see how we can deal with it. What can we do to overcome it? How do we manage these outages and these incidents? What do we learn through practicing this on purpose, which is a tremendous way to understand your applications and your systems before they go wrong.
Absolutely. So I'm just, you being a long-time performance engineer, we've both been in this industry for a while. Back in the day, we used to do things like soak tests and stress tests to try to break the system. Is chaos engineering just a cool word to get people more involved in performance testing, or is it something completely different in your mind?
It is different. It is a different approach. It actually works quite closely, hand in hand with load testing, different styles of load testing. So, with load testing, I think we wanted to kind of do two things. Like we want to ensure that our traffic profiles work, that our application responds to what we expect the load to be, right? And so we have our different styles of load testing, and as you say, like a soak test or a stress test, where we're kind of strategizing how we throw that traffic at the application, and then seeing how the application responds. We're adding something to the mix with chaos engineering because we're still going to do that, right? We're still going to send the traffic. We're still going to load test. We're still going to do these different styles of load tests. But then we're going to unplug something, or then we're going to introduce network latency on purpose. Then we're going to introduce process dying, or taking a pod offline, or something like that, right? So different kinds of fault injection that we do on purpose during the load test, and then gauge how that affects the application, what happens to downstream and upstream dependencies, what happens to our service levels and the different indicators that we're watching as we perform these tests. So we're still kind of doing it in a load testing environment. We're still sending that same traffic from our load generators, styled however we designed it. But then we're injecting faults because we know they're going to happen. What happens then? What do we learn? What do we expect?
Absolutely. So why do you see more companies embracing chaos engineering? Has technology changed since last time we talked that makes this easier? Like you mentioned Kubernetes taking off. Is it because we're able to create more realistic environments now and actually play around with turning things on and off, which makes this type of testing actually more feasible for companies?
Yeah, I think it's another interesting tension that's happened. We've tried to reduce the failure surface, the surface area of things that can fail, by containerizing them, or by releasing, short iterative releases with small changes. But at the same time, with the adoption of cloud and with the adoption of orchestration like Kubernetes, we've increased the complexity tremendously. So what we've done is, in our individual projects or services, if I'm on a team that's responsible for one microservice, we understand that very well, and we can test it really robustly, and we make small changes and we know what breaks it. But once we put that out into the ecosystem, where there are, dozens or hundreds of other services interacting with it, where it's running on complicated infrastructure in AWS or Google Cloud or Azure, what have you, and all these different Kubernetes orchestration components, schedulers and APIs and all these things that all become places where it can fail. And so while to us in our work, we understand it pretty well. But once it's out in the wild, in production, the complexity is just monumentally larger than it's ever been. And any failure in that environment can have a ripple effect, right? So if some third-party service goes down, what happens to our application? And you're not going to know until it happens unless you do chaos engineering. In chaos engineering, we can model that failure so we get ahead of it, right? So instead of waiting until the outage happens, when an outage happens, everybody panics, right? We're all, the adrenaline, shoots through the roof. We're all trying to get the service back online, or reverting a deployment or something like that. And it's hard in that frame to digest what's happening clearly, to understand it, to reason about it, to prepare for it next time, and so forth. So we end up doing a post-mortem or something like that, where we try to do that after the fact. But so much has been lost because maybe we weren't taking good notes, or maybe we were too frantically just trying to get things back online. With chaos engineering, and this is a great use case for chaos engineering, reproduce that outage on purpose, right? So last week, something went down. We had this chaos, or sort of natural chaos, uncontrolled chaos, introduced into our environment, and we all panicked, and we got it back online. We feel pretty good about it, but we're not really sure what we learned. This week, let's set aside some time, reproduce that outage, and using a tool like Gremlin to do that, we can create those same conditions. Then we can do what we call a game day or a fire drill, where we practice our incident response, right? Create the conditions, get the right people involved, make sure we're using Slack or Teams or what have you for collaboration, check to see that our observability solution is giving us what we need, the right alerts, the right telemetry, Do we have any gaps in our monitoring? Is this something we would have known about in advance if we had only had the right telemetry for it? So chaos engineering helps us work with this explosive complexity that's happened over the last 5 or 10 years.
Absolutely. So speaking of this complexity, then how does someone even know where to focus in on? I know you mentioned like known issues or that may have happened in production, trying to replicate them when you're trying to create the conditions. But is it truly chaos that that's what chaos engineering is for? It's able to find these things without you really knowing where to focus your energy in on.
There are a couple of ways to answer that, I think. So I think one of the things that we like to keep reminding everyone or educating folks about is that, in the early days, and a lot of people first heard about chaos with Chaos Monkey from Netflix, right? And our founder was a part of that, part of Netflix, also part of Amazon. Our founders, both of them, come from practicing chaos in its early days and kind of learning a lot of lessons from the initial approaches that were taken at these large companies. And so a lot of people think of Chaos Monkey, which would, back in the day, would just randomly shut down EC2 instances. And you just kind of never knew when that was going to happen. And you kind of you were forced to learn as a team, forced to learn how to adapt and how to, architect your application to better handle those unpredictable outages. We don't really do that anymore. I mean, you certainly could, but what we suggest is controlled chaos. Think about what you're going to do. And so we gauge it, we guide ourselves using a kind of scientific process where we try to understand the system as it is right now, kind of the steady state, observing the system, understanding the baselines. Then we hypothesize about what we think will happen if a dependency goes down, or if latency increases, or if a process dies, or whatever kind of system failure we're talking about. We hypothesize about that. I expect that, if this non-critical, let's say we have something like a banking application, and we have a user profile service. It's a place where a user can go and update their address or something like that. Let's say that that's not as critical of a service as the balance reader service that shows the user how much money they have. Right? These have different criticalities for the user experience. The user might be able to tolerate not being able to change their delivery address or something. Whereas if the balance doesn't show up on their account page, they're going to freak out, right? So we would reason about those things. Like we might say, if that user profile service goes down, I expect that the rest of the application will behave as normal, as it usually does. I expect that profile service going down will not interfere with the balance reader service or the payment service or the mortgage application service or what have you. So we think about that, and then we use a tool like Gremlin to actually create that outage. So I would go into Gremlin and I would select that service, my user profile service. I would then take it offline using Gremlin. And then I would observe my application and look at the impact. Can I still make payments? Can I still apply for a loan? Do I still see my balance and do I see all my transactions? And if I do, then my hypothesis was correct. But I might not. There may be some underlying relationship between that profile service and the other services in my bank that causes chaos in a way that we didn't know about, the unknown unknowns, right? And so that's the whole point of doing the experiments. You have a hypothesis, you run the experiment, create that outage or inject that failure, then you observe what's really happening, take great notes, save those notes. You can do all this in Gremlin, by the way. And then, make the changes you need to make and do it again. And of course, over time, we want to automate these things as we get more experiments that we want to run reliably every time we do a release or a deployment.
No, I love that approach. It is you did a demo that's actually called the 5 steps of looks like the scientific method for chaos engineering.
Yeah, that's right.
One of the steps that seems the hardest to me, and it's always been the hardest for performance testing for me, was not necessarily creating the test, but actually analyzing the data. And that was when I knew I had a server, a database server. I knew the components that made up the system. Now, like you said, there's so many unknown unknowns. So if I had a problem analyzing where an issue was when I knew the known knowns, how do I know where to analyze the issue if I don't know the known knowns?
Yeah, that's a great question too. There are so many, like chaos engineering on one hand, what we're providing are ways to inject this failure, right? Consume some resources, CPU, memory, disk, what have you, or interfere with the network, either black hole something, just drop all network traffic, or increase jitter and packet loss or latency. These kinds of things that we're actually going to do. But from a higher level, we're strategizing. We have a reason for doing these things. And so these use cases become the lens through which we approach these experiments. And one really great use case, like we talked about recreating an outage or understanding the blast radius around dependency failure. Another really good one is validating our monitoring and observability, right? So I actually, just the other day, in a demo environment, had an actual legitimate outage, and I had to go figure it out. This is like not even me doing chaos. It was just, the application started throwing errors, and there were all sorts of problems with the front end. And I had to go inspect it, and I happened to be using the leading observability tool, and realized that I had not added the integration for Postgres. And I could see, to a degree, I could see in my logs that the database was the issue, and I could see when it started. But then I lost visibility. I couldn't get into the database metrics and actually understand the problem, which showed me a gap that I had in my visibility. So that's actually a really great use case for doing chaos engineering is, inject these faults, then go inspect and see if you can troubleshoot the issue. We do these game days, and game days, that's one of the real reasons to do a game day. We want to think about the experiments that we're going to run, but we also want to think about the people that are involved and the processes that we're practicing, the incident management processes that we have. And this is the kind of thing that could come up because we inject this outage, the team gets together, we're all collaborating on Slack, and someone is designated to go figure it out, right? Someone's designated to actually be heads down in the code or in the logs, try to figure out what happened to that outage. As part of this experiment, that person would have discovered that we have some visibility gaps or telemetry gaps in our database. And now we can fill those. We can add that integration, get those metrics. And when it happens for real production, we should be in a better spot. And of course, we can go validate it again with another exercise.
So would you say chaos engineering then is like a process that should only be done in a more mature organization that actually has some observability and telemetry in place, or do you see the opposite where it actually exposes where you're immature and where you then need to, like you said, maybe beef up your observability?
Yeah, I think absolutely it's something that you can adopt wherever you are, and you're going to learn different things because of it. If you're a team that's not done chaos engineering before, maybe you're still even just starting to adopt SRE practices. Right, you might not have even defined all your SLOs or your error budgets or things like that. It's a nascent team, and a lot of organizations are in this position. Maybe they're a newer company, or maybe they're a newer team coming together and starting to think about these more modern organizational practices. You might not know what you expect, and so a perfectly valid use case of chaos engineering is simply learning how your applications will break. Right, so you might still formulate some hypotheses, but you have nothing to go on yet. You're just starting from scratch. So it's a learning experience in that sense. You start to internalize how your systems interact with each other, where the ripple effects are felt simply by injecting 100 milliseconds of latency, let's say, into some service and realizing, wow, that actually breaks this other service totally unexpectedly. So that learning process is a very important part of chaos engineering, is to kind of discover the problems. Then let's say you're a very mature organization, and what you want to do is actually test your disaster recovery planning. Right, you already have, your application might already be architected, let's say, for regional failover, geo failover. You're running in production in AWS and US West 1, but you have failover to US East 2. You could actually cause that to happen and test your disaster recovery, your business continuity planning around that. And that would be, I think, a more mature use of the same kind of technologies.
Nice. So who owns chaos engineering that you've seen? Where does it typically lie? Who is it? The developers? To me, it's still, I don't think the word's out, even though it has become more and more popular, but who do you then say, well, this team should be doing it, or does it depend on what organization you go to?
Those are the two the teams that I'm thinking about kind of relate to the use cases I was just using. I think we talk to a lot of SREs, absolutely. We talk to a lot of DevOps teams. um, uh, from both a developer standpoint and from an operations standpoint. Um, that I would say is definitely where a lot of the interest is right now. People are learning about this. They understand the importance of doing it and why it makes sense, the value of doing it. But we also get a lot of interest from business continuity, right? From larger enterprises that need to test these, disaster recovery plans and they want to be able to actually run that kind of game day, which is much more impactful for the organization and the business than it would be for a DevOps engineer simply trying to make sure that the database is scaling properly or something like that.
I used to work for an insurance company. They used to do this like doomsday scenario every year. It was really hard, where they take down all the servers and they'd have to recreate it on another site. It seems like, and it took a
Yep.
lot of resources and time. It seems like chaos engineering for modern practices is what they could probably utilize for those type of scenarios, for sure.
Yeah, absolutely. I mean, what we're doing is creating that real disaster. I mean, obviously, we're not creating a hurricane taking out a
Right, right.
data center, but we're mimicking that in a way, right? And so it's shutting down all traffic from your application to an entire AWS region should trigger that failover plan, that automated failover, redirect the traffic and bring those other servers online or that other site online. And that's what we would do. We would actually cause that failover. They would trigger the conditions that would cause that failover to happen, and then you can verify and validate, just like we would with any other test, validate that the what we expected to happen did happen.
Nice. Now, you did mention earlier something called a black hole, and actually, I'm not familiar with this term. Is this a new term? What is black hole? Is this a Gremlin thing, or is this something that you coined, or what is it?
We might have. I think
Uh,
it's a lot of the chaos engineering is kind of growing in popularity, and it's a little bit new, and so there's some new terminology that's emerging. Black holing, the way we think about it, is shutting down all the network traffic from a service to and from a service. So we're basically making that service appear to be offline. Yeah, from a sort of Linux internals point of view, we're working with traffic control, which allows you to shape the network behavior the way you want. You can introduce packet loss, or you can have everything go out through one interface. One of the things we can do is just shut down all ingress and egress to that NIC, basically. And so it appears to the rest of the world that service or that server, what have you, is offline, right? So if we talk again about the bank, if that balance reader service, if we wanted to see what happens when that goes offline, we just select that pod, it's running in Kubernetes, and we just shut down all the network traffic. We block all network traffic to and from that pod. So to the rest of the application, it appears to be offline. Now, one of the things that these days, if you're running in Kubernetes and you have a liveness probe set up, Kubernetes should automatically schedule a new pod and roll that out. So one of the reasons, again, for doing chaos engineering, one of the ways you might think about it is to test that Kubernetes or whatever you're using for scheduling or auto scaling is doing what it should do. But we also will sometimes do things like disable that liveness probe and see how a sustained outage will impact the rest of the application. But a black hole is basically just what it sounds like. Everything just goes into a black hole, no communication gets through.
So you actually have a really great article on this. I'll have it in the show notes where people can actually dive in a little bit deeper. Along this type of thing, when you're talking about black holes, you talk about different sizes of black holes. And to me, I would think people would automatically go to like doomsday type black hole, supermassive. Is there value in all chains, or do you usually recommend they start small, or does it matter?
Yeah, it does matter. I think we do recommend that we start small, right? I mean, again, the theme for doing chaos engineering is controlled chaos, thoughtful experiments. And so we want to know what we're doing each step of the way. We call the impact that an experiment has, we call that the blast radius, right? Which is somewhat common terminology for any kind of outage or exploit or whatever. Like how big was its impact? So we think about targeting a small blast radius first. We want to internalize our understanding of what happens both with the chaos tool and with the impact to our apps. I don't know that unless you're talking about like disaster recovery, like we just were, that would be a good use case for black holing the entire system. But that's kind of a use case. It's more interesting to black hole parts of the system, I think, and see how the other services and other dependencies respond. Sometimes you'll inadvertently break something else. Like if the front end service needs to talk to that balance reader service and you break the balance reader service, what does the front end do? Does it just slow down? Does it time out? Does something else break? So black holing, to me, can be more useful in a surgical way. However, a broader attack, a broader chaos experiment that I think is useful is a DNS outage, because we see those in the real world. I think Fastly and I think Akamai both have had big DNS outages in the past six or 8 months or something. And that's the kind of thing that you can do with Gremlin. You can just simply select all of the components in your application with one little toggle, and then just break DNS for 5 minutes and see what happens. So those tend to be kind of fun, because a lot of that impact, you're unclear, like which services are even using domain names, host names to look things up, or which ones are going to IP addresses and won't be affected by that. So you can learn a lot by doing that, reproducing that kind of outage.
Nice. Now, kind of off topic, or just kind of changing the topic a little bit, is just came to my mind. I'm just thinking of people that came up as performance testers, and it seems like now it's becoming rarer, but they're morphing into things. If someone's listening, I always get asked, like, I'm a performance tester, what should I be focusing in on? Do you think they make excellent chaos engineers, or do you think that's something they should include in their toolkit, or, as you said, it should just be like a DevOps SRE type of thing, and
No, I
performance testing never overlaps?
Absolutely, it's an evolution. It's an evolution of the performance engineering toolkit, without a doubt. I think that is there are two sort of what the word I'm looking for is sort of tools that are sort of hand in glove for chaos engineering, or hand in hand. And one of them is load testing, or performance testing, and the other is observability. And so these two elements are really important. And I think as a load tester, as a performance tester, I would be thinking more probably in terms of resilience, right, rather than chaos, right? And we talk about that a lot right now in terms of the jargon of the industry, because chaos has these connotations of being just taking a sledgehammer and randomly breaking things, or the monkey or the simian army and those kinds of things. Whereas resilience has a little bit more of a sophisticated sound to it, maybe. But the idea is that's what we're doing. We're actually, as performance testers, we're traditionally used to exercising our application based on the traffic that we're sending to it. So we're seeing how the application responds to a particular load profile, or maybe as we said earlier, a soak test over many days, or a stress test, and just maximize everything at once. What we can do now is introduce those faults, or inject those failure modes, to further understand how our applications respond to that kind of stress. So it's not just about request and response timings, or the metrics that we're collecting when there are 100 concurrent users or something like that. It's more about understanding that when a condition in the application changes, and we do that on purpose. And so, okay, my load seems good right now, and in my staging environment, I'm running whatever it is, 1,000 concurrent users, things are responding, the Cs are calm. Let's inject 500 milliseconds of latency. Then what happens? Then what kind of response times are we seeing? Where are we seeing errors? Are things queuing up at the database? Those kinds of, we create conditions that take us further into that process of understanding how stress and load affect our application.
Nice. So, Michael, you've had a long career. It always seems like you're always at a hot company. I'm always looking at 2022. I do like a podcast. I do like a blog post on trends for 2022 and beyond. It seems like chaos engineering was one of the trends I had for this year. Any other trends you see that performance engineers or SREs should know about, that you're hearing more and more about as you're in the field, working with different companies?
That's a good question. I think that building on what I said a few minutes ago, I think resilience is kind of a new way of thinking about all of this. It's not a new idea, but I think we're starting to see that term used more. And, we've been kind of building up to it for years with all sorts of fault tolerance that we've tried to build into these applications. but it's getting kind of its own kind of place on stage, or it's getting its own chance to stand out as a topic that we think about, which I think just using the term resilience causes us to think about it in a slightly different way. We've been saying reliability for a long time, right? Reliability is really about our SLOs, right? It's really about are we hitting the goals or not? Or are we exceeding those goals? We know how to track that, and then we think about our reliability based off that, right? Reliability is a state. We're either reliable or not. Whereas resilience is more about how our systems respond to outages, and where that tolerance is greater or smaller, and how we then, this is going to be a feedback loop back into how we develop systems, how we manage outages, what practices we adopt as SREs or as DevOps engineers. So I think that that's an emerging space, and I think there are going to be a lot of interesting developments of patterns, ideas, products, tools that are going to come in that silo, if you will, or in that kind of under that banner headline of resilience.
Awesome.
That's how I think about it right now.
Yeah,
anyway.
I love it. I love it. I'm gonna
being at Gremlin, I think about it every day.
Very cool stuff. All right, Michael, before we go, is there one piece of actual advice you can give to someone to help them with their chaos engineering SRE efforts? And what's the best way to find or contact you?
Well, I'm easy to find. I'm michael.sage@gremlin.com, and anybody's welcome to reach out. I think I would suggest that folks look into a couple things that we do, and one of them is boot camps, chaos engineering boot camps. I think this is new for a lot of folks, and we do boot camps pretty regularly, a couple different levels of them. So newcomers, there's a boot camp 101, I think we call it, which is a place where you can come and there are hands-on exercises. We provide all the tools and environments that you need. So you literally show up, we'll teach you how we do chaos engineering, hands-on keyboard most of the time. Great way to learn about the concepts, but also working with other folks, with little breakouts and things like that. The boot camps are phenomenal. And we also offer certification, right? So Gremlin certification, you go to gremlin.com/certification, and you'll see our program there. It's a great way to kind of get that badge, as well as learn about chaos engineering, and kind of take your skills up to the next level. And the boot camps and the certifications work really well together. Go to a boot camp, you should be ready to get certified. And then the third thing I would say is start thinking about game days if you're not doing them. I think game days are really important. It's really important to get the muscle memory about how your teams work, how your applications work, sort of like start working on those things. If you don't have a good incident management process, develop one and then practice it and use chaos engineering to trigger the actual conditions that are going to help you exercise all those components, make sure folks have the right roles and responsibilities. And when the outage really happens, you'll have that muscle memory to help you through it and help you feel confident about solving those problems.
Great advice. Thanks again for your performance testing awesomeness. For links to everything of value we covered in this episode, head on over to testguild.com/P75. And while you're there, make sure to click on the Try Them Both Today link under the exclusive sponsors section to learn all about SmartBear's two awesome performance test tool solutions, Load Ninja and Load UI Pro. And if the show has helped you in any way, why not rate and review it in iTunes? Reviews really do matter in the rankings of the show, and I read each and every one of them. So that's it for this episode of the Test Guild Performance and Site Reliability Podcast. I'm Joe. My mission is to help you succeed with creating end-to-end, full-stack performance testing awesomeness. As always, test everything and keep the good. Cheers.
Thanks for listening to the Test Guild Performance and Site Reliability Podcast. Head on over to testguild.com for full show notes, amazing blog articles, and online testing conferences. Don't forget to subscribe to the Guild to continue your testing journey.